Logical semantics is the mathematical study of meaning. In a textbook, this idea is defined through concepts such as domains, rules, and interpretations. But these are such universal notions that one can think of many examples of them. The point of this video is, why not have a little more fun with the examples? I hope that the social setting can make rules, domains, and interpretations more tangible, or at least more entertaining. Our society consists of 3 agents, and hey, sometimes they say 3's a crowd. Alice, Bob, and Carol. Each of them has their own interpretation of the state of their society. Let's start with Alice. She and Bob clearly have some sort of understanding with each other, so much so that, in Alice's interpretation, Bob is her leader, and as such, she offers him her support. Alice goes so far as to mention Bob, presumably out loud, and believes that Bob is persuaded by her. Encouraged in this way, she might conclude, he mentions himself. Eschewing convention, we consider Carol next. Very much the third wheel in our little society here. Not knowing the intricacies of Alice and Bob's relationship, Carol believes that in fact, Alice is Bob's leader. Carol is very independent. They are their own leader, thank you very much, and thus they support themselves. But because they see Bob mention himself, they conclude that Bob supports himself as well. So far, so good. But now we come to Bob, a rather odd, if not to say solipsistic, character. Like Alice, he is entirely ignorant of Carol's existence, but what's more, it seems that Alice might be mistaken in thinking she has persuaded him. Bob knows that Alice mentioned him, and he mentions himself too, but he does not reciprocate Alice's support, nor does he seem to be aware of it. So now we come to our main question. Do Alice, Bob, and Carol agree? Or if they do disagree, about what and how? At first glance, one might quite justifiably say that they all disagree with each other. But do they? One way to answer this question is to introduce the distinction between syntax and semantics, and explain what it means for an interpretation to be a model of a program. Let's start with some definitions. I know, but I promise they'll be as light as possible. Let's begin with syntactic structures. So far, we haven't yet encountered a rule, so here's an example. Read from right to left, this says, if X mentions Y, then X supports Y, with the arrow representing a conditional, that is, if-then statement. We can think of them as little in-out machines. If the right side of the rule, the body, is given, then the left side, called the head, is obtained. We often refer to this idea as a rule firing. A rule without a body is an axiom, that is, it fires automatically and its head is always obtained. Together, a collection of rules and facts is called a program, though we will abuse the terminology slightly to refer only to a collection of rules in this case. Crucially, rules don't tell us anything about the meaning of things like supports or leader of. Of course, to us as humans, these words naturally bring up certain associations, and this is much the framing of our little social setting. But put yourself in the shoes, or maybe a case, of a computer. From its perspective, the symbol, leader of, has just about as much meaning as this symbol. All the computer knows is that given the body, the rule fires to obtain the head. This is syntax, a mechanism for manipulating symbols based on structure alone, without any knowledge of its meaning. So, what then is semantics? Well, semantics is exactly the assignment of certain sets of symbols to the symbols in the syntactic rules. We've already encountered the interpretation. This is a set of assignments for domain, functions, and predicates. The domain is the universe our interpretations live in. That is, the set of things. Importantly, variables in the program can be instantiated into members of the domain. For our purposes, the domain consists of people. Functions are the same as in math. Given one or more inputs, they produce only one output. In this sense, they are somewhat like rules, but don't mix them up. Functions are defined over the domain. All the inputs and outputs in our case are people, not facts or collections of them. So Bob is the output for the input Alice here. Predicates are like functions, except they map to either true or false. An instance of a predicate is called a fact. The difference between syntax and semantics is subtle. At first glance, not only have we introduced a truckload of jargon, but perhaps more importantly, aren't we just splitting hairs, you might ask? So you decided to call leader of a symbol. How is the tuple Alice, Bob any less symbolic? How is it meaningful? One answer is that, crucially, a syntactic structure, the program, can result in multiple semantic structures, interpretations. Put another way, syntax sort of exists in a vacuum. It gives us the rules for manipulating symbols, but it doesn't tell us what things in our domain correspond to those symbols. Someone, or something for that matter, supports their leader, the syntax says. Alice supports Bob, is Alice's interpretation. In unexpected ways, two rather different interpretations might agree, while two seemingly similar ones are irreconcilable. How we define these notions of agreement and what all of this might mean for the social setting is precisely our focus. Let's take a closer look. A model is an interpretation which satisfies the program. This is represented by the turnstile symbol. Let's illustrate this with Alice's interpretation and our example program from earlier. As we saw, Alice defines her domain to consist of herself and Bob. For an interpretation to be a model, we must ensure that all the facts contained in it, along with the chosen assignment of domain and function symbols, are closed under the application of rules. This means that for any instance of a rule body in our interpretation, the instance of the head obtained by the rule firing, remember, if, then, is also in our interpretation. And that's it. Now let's do the same with Carol's interpretation. Though Carol is our third wheel, it is in fact Bob who is the odd one out here. His interpretation is not a model of the program because it is missing facts. Get with the program, Bob. And that's basically all there is to it. If you've managed to follow this process, congratulations! You have learned, short of a couple of technical wrinkles, model-theoretic semantics. And, to answer our initial question, it turns out that, in fact, Alice and Bob are the ones who disagree. To parse this into the social setting, while Alice and Bob certainly share facts in common, they do not, so to speak, agree on the rules of the game. Perhaps Alice and Carol, being more trusting, see recognition of a leader as a prerequisite for supporting that person. Bob, on the other hand, is rather distrustful. He does not believe that those who recognize him as a leader necessarily support him. So where does all of this leave us? I can already imagine the skeptics among you ready to tear apart both the modeling assumptions of our three-person society, as well as the conclusions. Carol and Alice agree? Really? So let's outline two main objections in detail, the closed world objection and the program choice objection. Let's begin by scrutinizing one thing that many of you will have surely noticed by now. Consider the predicate support, and in particular whether one person may support multiple people or just one. As it stands, our program is agnostic here. The program tells us that a person supports their leader. But does this also mean that it is false to say that they support anyone else? That is to say, should we consider the statement not supports Alice, Alice, to actually be part of Alice's interpretation? As it turns out, negation presents an enormous headache for logicians. At the very least, this is because we as modelers must decide what we know about the real world outside of our program and its interpretations. There are two approaches to this. The closed world assumption means that we assume any fact not to be explicitly given in our interpretations to be false, End of story. The world is closed, and that our programs and interpretations are a total representation of it. If Alice does not explicitly believe that she supports herself, then she doesn't. The open world assumption is much less ambitious. It does not purport to know everything about the world. Instead, a fact which is not directly asserted in an interpretation is just unknown. Perhaps Alice does support herself, and we, as the modelers, don't know. In a realistic setting, maybe we are pollsters who asked Alice about her support for the candidate Bob, but never bothered to ask her about herself. Our example so far has taken the open world approach. If we instead took the closed world approach, our interpretations would look a little more cluttered. But the upshot is that we may recover some of our intuition. For example, now Carol and Alice contradict each other directly. Interestingly, both are still models of the program. Now, let's consider our second objection, namely that the entire solution hinges on my choice of the program. Where did this program come from? And why should we use it to gauge agreement? And honestly here, I'm guilty as charged. The choice of this program in this context was completely arbitrary, so you're asking the right questions. Remember that an interpretation, which is a semantic structure, can only be considered a model relative to some specific program, a syntactic structure. Had we chosen the following, very simple program, we would find that all three of our agents provide models of it. So really, both the closed world and the program choice objections are entirely legitimate. But that is, in a sense, exactly the point of this video. Let's wrap up by stepping back from the technical details to see what all this semantics could mean, pardon the pun, for the social setting more broadly. Fundamentally, model-theoretic semantics shows us that there are different ways of disagreeing. Yes, two people might disagree about the basic facts of the case. However, perhaps more perniciously, even two people who seemingly agree on certain facts might have fundamentally different perspectives on how the rules of society work. If we believe that Alice and Bob will behave the same, for example, show reciprocity, we would be mistaken in our predictions. And this is where an interesting metaphor, the social contract, comes in. Roughly, the social contract is exactly what it sounds like, an agreement under which society operates. Remember the program choice objection? Well, if I was to go out on a limb, I would say that this is the very notion of the social contract. Billions of agents navigate the world, constantly making their interpretations. The social contract is the program which best fits these interpretations. Now the phrase best fits is truly doing a colossal amount of work here. What factors, for instance wealth, age, or gender, mediate this fit is very much a question for the modeler. But importantly, this offers us a tantalizing perspective on discovering social contracts, the field of inductive logic programming. This is a family of machine learning techniques which discovers syntactic structures underpinning given semantic ones. But that is a story for another time. For now, I hope you enjoyed the social example of model-theoretic semantics. Thanks for watching.